Okay, sorry. All right, so what we've got here is, just basically raw data that we collected from our from the lab that we did yesterday. Okay, we already typed in, our masses and all that kind of stuff and our times in here. I'll put in my displacements in a minute. So eventually we're going to want to, type in some more numbers, and eventually we're going to want to copy this thing over into a Google document file, right? But you'll notice, like if you look in this column A, a lot of my row titles don't fit into the space that's given, right? Okay, so there are two ways that you can fix this. All right, option one is just embiggen the width of the row. Okay, which is fine, but the problem is if your data table gets too big, then when you try to paste it into your document, it's not going to sort of fit on the page. You know what I mean? It's going to be like too wide. So when I create a data table, I'm always real conscious of sort of how wide my rows are, or columns are, how wide my columns are, because you want to make sure that it all fits. All right. So there are a couple ways of doing this. So one way of doing it is, it turns out that if you go in up here at the top, so if you go between any two columns, see that how my arrow turns into a double arrow? All right. If you double click, it auto fits it to the size.
Whoa.
Okay. All right. Now, cool. Real quick little trick, right? Okay. So sometimes that's a good thing, sometimes it's bad, because like later on we're going to type numbers in here, and that's not going to give us enough space. So I'm actually going to undo that. But just know that you can do that, and we're going to redo it later. All right, so I'm going to undo it for a minute. All right, now, doing that to column A doesn't help much, right? All right, so here is another cool trick that you can use. So let's look at some of the biggest columns. I'm looking at this experimental acceleration. That guy's causing us problems because it's real wide, right?
Yeah.
So what I'm going to do is I'm going to go up to Format. See down here where it says Text Wrapping?
Yeah.
Right now it's set to Overflow, which means if you make your columns narrower, it'll just overflow into the next column. We don't want that. We're going to change it to Wrap. And what that means is it's going to wrap onto multiple lines. You ready for this? Boop. Sorry? Oh, Adjust Star? I don't know. It's the one that is under, it's the third one down in this little space. All right, so let's do that in some of the other ones. So like predicted acceleration, let's do that. Format, text wrapping, wrap. All right, and it's not happening for me because I've got it all set too wide. So let's narrow it. Aha. All right, so now I can see which ones are my problem ones. So,
General, and just
oh, I don't know. Does that work?
yeah, it worked for me.
Oh, right on.
Oh, right on.
Oh, look at that. Yay for... All right. Thank you. I didn't even know that worked. I don't know why I didn't. I use that all the time. I just never did it with that function. Okay, so what Max just informed us is you can select a whole column by just clicking the letter at the top of it, and then go to Format, Text Wrapping, blah, 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 blah. Good? I know, the computers are rough. Do the best you can. All right. Daniel, you okay over there?
Yeah, sorry.
Oh, I got you. Yeah, totally. As long as you can see what's going on.
Yeah.
You sure?
Yeah.
All right. Okay, so is everybody good with that? All right, so that was sort of our first task. Now, we're going to clean up the formatting of this later on. Like right now, my numbers are centered, but these numbers up here are left-oriented, right? Or left, what's it called? Aligned? Justified. Thank you. That's what I'm looking for. All right. Yeah, eventually we'll either center them all or left justify them all or whatever. Okay, so now here's one of the really cool things about using a spreadsheet to make a data table. You know all that time you spent yesterday finding average times and finding accelerations and blah, 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 blah? We're going to let the computer do all of that work for us.
That's not cool.
Well, it's not cool because you did it yesterday, but from this point forward, you'll never have to do it again. So that is cool. All right, so check it out. Accelerating force. What made the system move yesterday? When you let go of the cart, why did it go? Gravity's a good answer. I need more detail. Gravity on the little hanging mass, right? You guys agree that it's the force of gravity on that hanging mass that makes everything go, right? So in this trial that I'm looking at, the mass of that hanging mass was 20 grams. So if I want to find the force of gravity on it, I need to do two things. First of all, grams are not our friend, so we're going to convert to kilograms, right? And then I'm going to multiply by 9.8. And that'll give me my accelerating force, right? So check it out. Accelerating force. Here's what I'm going to do. Anytime you want the spreadsheet to do a calculation for you, you type equals. And that says, hey, computer, I'm about to have you do some work for me. All right? So here's what I want it to equal. I want it to equal whatever my hanging mass is. So did you see that I clicked on the mass?
Oh.
And see what it did? It put in B2 right here. All right? So now I want to divide that by 1,000 to convert to kilograms. You hit the slash button. I don't mean the Guns N' Roses guitarist. I mean, because that'd be cool if he had his own keyboard, but he doesn't. So I mean the little button that looks like this. All right. All right, so is everybody good with that? Everybody has divided their mass by 1,000, right? Now what do we do? So times asterisk 9.8 and hit enter. All right, so if you did it right, you should have got an accelerating force of 0.196 newtons. I will show you that in a minute. Huh? All right, is everybody good?
Wait, you hit enter after that?
Hit enter after you've got your equation in.
Okay. I just went down mine.
So does everybody have zero? Raise your hand if you don't have 0.196 right now. What's going on?
I'm so bad at computers.
Okay.
Alright, second round.
All right, everybody good up to there? We got a lot to get through, you guys, so is everybody good? Holy cats, how did it get so late? All right, next thing, total mass. Well, the total mass is going to be this plus this, right? So I'm going to type equals. Now, don't do it yet. We're going to add two things, but then we need to convert to kilograms. So I'm going to add and then divide by 1,000. So what do I have to do before I add? Parentheses. So I'm going to do parentheses, this guy plus this guy, close the parentheses, divided by 1,000. If you're not sure what to type, here's the equation that I typed right up here in this little window.
So, wouldn't it just be 2 for all of them, though?
It is going to be 2 for all of them, but do it this way. You'll see why in a minute. Because they're not constant in part 2.
Can we, like, can I just type in 2 for the top, and then 2 for the equation for the bottom?
We're not going to type for the bottom. Trust me. All right, is everybody good up to there? Everybody got a total mass of 2?
Yeah.
And you calculated it. You did not just type in the number 2, correct? There's a reason I want you to do it this way. What's wrong, Margaret?
Okay,
Do you want me to do it again for you? You got it? Daniel, you doing all right over there? All right, is everybody happy? All right, next one, predicted acceleration. All right, so check it out. The whole system is accelerating because this force is acting on it, and it's this much mass. So how do you find the acceleration? Acceleration is net force. We're assuming that's our net force divided by mass, and then hit enter. Good, and so you should get 0.098. Is everybody good up to there? Raise your hand if you are confuzzled. I hate teaching sitting down. Are we all good? All right. Okay, so now you ready for this? So now we got to do all these other ones. That seems like a drag, right? No, well, yes, because we're going to drag. All right, so check it out. I'm going to highlight those 3 equations I just put in. All right, just highlight those 3 cells we just did. Sorry, that was a terrible joke. Everybody got that? See this big black or big blue square here? Click it. See how if you hold the mouse over it, it turns into a plus sign? Okay, what I want you to do is click and hold, and then drag all the way down to the end, and let it go. Holy cats. Yes. Sorry?
What
What was the joke? Oh, a drag. We dragged. It's a drag. Never mind. It's a bad joke.
No, that's how I'm sourcing for the equation.
I don't know. I'm not sure. All right. Does everybody have that done? Nobody said, ooh. Isn't that cool? All right, Max, here's why I didn't want you to do that. All right, now. So now what I want to do is, so we've done all of our calculations up here for sort of part 1, right? What I want to do is all of this stuff that I just did here in part 1. Oh, sorry, I didn't copy it all the way over. You want me to do it again? Yeah, totally. All right, so is everybody here?
Yeah, yes.
You're good with that, Sabo? Margaret, you good? Yep. Yeah, I don't know how you'd use that because you don't know your PF. Let me come back to you. You could find your average velocity and then double it to get your final. There's an easier way to do it. I'll show you in a minute. All right, Sebo, Marge, are you guys good with up to here? Margaret, sorry. I apologize. Shh. Hey guys, we really have a lot to get through, so if we can keep our voices. All right, Margaret, are you good? Sebo, are you good? Like, good, I should move on, or show you how to do this again? Okay, so to reiterate, all I did was I selected those 3 equations, and then drag them across. All right, so everybody's good up to there, yes? All right, so what I was trying to say is this. So we've got all of this data that we just put in to part 1. We want to do the exact same thing in part 2, right? Yeah. So I'm going to hit Control-C for copy. So I just copied all of that formula work I just did. I just hit Control-C. Alternatively, you can go to Edit and Copy. Then I'm going to go down here. Notice I rolled down. So now I'm looking at my part 2 data. And I'm clicking in the cell where I started. And I'm just going to do Paste. Control-V. Oh, except it didn't work for me. Whoa. Control-C. Control-V. There we go. Good? Did that not work for anybody? This gave some weirdness for a few people last hour. Okay, guys, so next thing we need to do. We need to calculate these bottom rows. We got to find our average time, our displacement, and our experimental acceleration, right? So I'm going to kind of do the same thing. I'm going to figure them out in this top one, and then I'm going to copy them down into the bottom one. All right? So average time. So there's 2 ways you can find average. You can do time 1 plus time 2 plus time 3 and divide by 3. Or I'll get to rounding in a minute. It's on my list. Okay, so one way is to add them up and divide by 3. The other thing you can do is this. Most spreadsheets, Google Sheets included, have some built-in functions. So I'm going to type equals, and I want to take an average. So let's see if there's a built-in function for average. I'm just going to start typing the word average and see what happens. A-V, oh, look at all these functions. Oh, there's average. All right, and then what do I want to take the average of? Oh, these 3 cells. And then close your parentheses and hit enter. Does that make sense? Did I do that too quick? Everybody good? No? Who did I lose? So you just type equal average, and then parentheses. In the parentheses, you highlight the 3 cells you want to take the average of.
That's not what I did.
That works too. You're good with that. All right, everybody good? All right, now, your displacement. For you guys, your displacement is going to be a number like 0.53 or 0.62 or something. Not, as a lot of people in my 4th hour thought, 0.05 or 0.06. All right, so type in your displacement. I have a ridiculously large displacement. Mine is 1.8. Yours will not be that big. All right? And then experimental acceleration. So here's how we're going to find the experimental acceleration. Here are the things that we know. We know that our cart started with an initial velocity of 0. We know our displacement is, in my case, 1.8 meters. We know the time that it took is whatever your average time is, right? So remember this guy? All right. I left something off. What did I leave off? Plus VIT. Why did I leave it off? VI is 0. Solve this guy for A, and you get 2 delta x over t squared. So that's how we're going to find our acceleration. All right. So watch. Go back to this guy. I already hear people saying equals. That's what I want. All right. So equals. Let's see. I wanted 2 times my displacement. I'm just going to click. Divided by my time. How do you do squared? Anybody know? Caret. Yep. So it's shift 6, because that's where the caret is, and 2.
Okay, so we're going to equals the time.
Friday, you good? You want me to do it again?
Click that, and then you just click on time.
So it's equals 2 times displacement. So I'm just going to click in the displacement square. Then divided by, I'm going to click in the time square. And then do caret 2. Oh, not 23, 2. And hit enter. Yep, it should be 0.0 something small. 0.07, 0.08, 0.06. Sarah, are you good? All right, so I think you guys have figured out where we're going from here, but now that I've done these 3, what am I going to do? Just drag them across, right? So drag these guys all the way across. There's all those. Good. Then I can Control C, copy it, go down to this cell and paste it, and my data table's full.
Do you have to drag and place like the average time in the displacement part too? Because I just dragged the bottom like or with experimental acceleration. Will it not turn out right?
Say that one more time.
If I don't drag the time and the displacement with it, like the 3 rows, I just dragged the bottom one.
You just did this?
Yeah, and then I copied that and then put that at the bottom.
Yeah, that's fine. But then you have to do the time separately too. Yeah, that's fine.
What was the experimental equation? Is something squared?
Acceleration is 2 times displacement over t squared.
Over t squared. Okay.
All right. Are we good? Yes.
So, what would the displacement be around?
Like, thank you. Okay, so let's talk about our sig digs then. So this total mass, it's 2, but it's more precise than that, isn't it? I want more decimals after that, because it's like 2.000 kilograms, right? Because it's to the nearest gram. So see up here where it says 0 with a little arrow and 0 with a little arrow? So you can either decrease decimals or increase decimals. So here I want more decimals. Let's see. 2.0, 0.00, 0.000. That's to the nearest gram. That's what I want.
Okay.
Follow? Cool. And then my predicted acceleration, I don't know. Technically, I guess that should be to 4 sig digs. I don't know why I'm being weird about it. So let's just add a decimal on these. And I know I haven't really technically taught you guys how to do sig digs, so don't get too bent out of shape about this. Yeah, so basically, everything between cart mass and predicted acceleration has 4 decimals, 4 significant digits. I'm not going to get fussy about this, but eventually you'll need to know how to do this, and that's how you do it. Up through predicted acceleration. Good? All right, so the next thing that I'm noticing, I'm going to monkey with the decimals again in a minute. Well, let's do that first. Yes, 4 sig figs on these columns.
If you select these
Well, I think you have to select the items individually. What's that? Oh, gotcha. All right, so just, whatever, however many decimal places you want. All right, so I'm not going to get super fussy about this, but just this is how you modify it, okay? Like, so something that would drive me bonkers is this column down here, or that row down there, right?
Yeah.
So let's fix that. So check it out. Let's see, our times are probably only accurate to three digits, right? Right? So that means our average time is only 3 digits. So when you did your calculation, your average time is a whole bunch of decimals, doesn't it? Mine don't because of the numbers I picked. But so what you're going to do is you're just going to click decrease decimal until you get down to 3 digits. Okay? Now, my displacement is accurate to the millimeter. So right now I'm at 1.8. That's only to the decimeter, right? So centimeter, millimeter. So 3 places after the decimal. For you guys, yeah. All right? Finally, experimental acceleration. 3 places after the decimal. So decrease your decimals till you get down to 3 after the decimal. Cool? All right. So, and then unfortunately you got to repeat it in the bottom step too. So
I don't mind it. I do not mind it. That's so cool. Now, what do I need?
all right, so get all your decimals sort of, so they're reasonable. I'm not going to be super nitpicky about it. If you've got 1 extra decimal place or 1 too few, I'm not going to get bent out of shape about it. All right, and then give me a thumbs up when you're good there. I gotcha, Daniel. Good? Sorry? Oh.
Absolutely. One more.
Do you want this back?
Oh, this is my list of things I'm supposed to teach you right now. That was my lesson plan for the day. Is that bad? All right, are we good? Yeah.
So are we doing,
I'm really not going to be anal about it. As long as you're in the ballpark, I'm happy. 3 or 4, anywhere in there, I'm happy. All right. I really should have taken 3 days at the beginning of the year and taught you guys how to do sig digs. I didn't do that, so that's on me. It is what it is. All right. Are we good? All right. Now, we want to make this all pretty. So, first of all, is this bothering anybody, the fact that the alignment is different? All right, so I'm going to select everything. I'm just going to hit Control-A, highlight, and select everything. All right, and then right here, it's got, just like it would on Microsoft Word, it's got your alignment. So do you guys want everything centered or left justified? It doesn't matter. Pick one. Centered. All right, we're going to center everything. Bam, there you go. Everything's centered. All right, next order of business. Let's see. Oh.
Yeah, it doesn't do it for both.
Yeah, that's weird. It didn't do both. Okay, so center everything. Good. All right, next order of business. These columns are wider than they need to be.
Yes.
So I'm going to auto-fit them. Now we can auto-fit. Do you guys remember how to do that?
Yeah.
Double-click. Double-click. I know, doesn't it look nice? I know the bell's about to ring. Let me show you 2 other things real quick before we go. Everybody good? If you, yeah, I mean, do what looks nice to you. As long as you're able to fit it on the page, you're good. Oh, that's it. Darn it. Okay. Make sure you know where it's saved. Log off, close it, and plug them back in. I got to deliver these to another teacher. Your homework for tomorrow is worksheet 4.3.